Sandrine, and I think the title on the website and in the leaflets is a bit different, but it's still the same. So I'm going to talk about data and models, specifically in the food and nutrition space, and what you can do with it. So I have a couple of case studies. And also thanks very much for inviting Prem Global to this event. I'm very honoured to speak among such great presenters, so hopefully I can deliver here. So yeah, okay. So about us, so Prem Global, we're an Irish-based company. We're an independent data science and technology company, and the different case studies that I'm going to present, they were funded by government partners and industry. This is a picture of one of my colleagues, so it's not a stock photo, but it's actually a person that I'm working with. Yeah, and we specialize heavily in the food, nutrition, and food safety areas. So just briefly the content, I want to talk a bit about what are the challenges when you talk about data science. It's a very kind of popular area at the moment. There's a lot of buzzwords, but what does it mean for food, for nutrition and health? And I'm going to talk through some case studies that involve predictive modeling, which sounds very fancy, but it can be, I think, straightforward. So what are the challenges? So I just wanted to kind of show that data science is it's a huge area, and it's overall a multidisciplinary approach. So you do need a lot of different backgrounds, ranging from maths and stats to computer science, but last and not least, the domain knowledge, because you can do a lot of number crunching, but if you don't know what you're looking at, it's kind of very hard to make sense of it. And within data science as well, you can look at predictive models, and that's what I want to focus on a bit more today. So what are the challenges when a researcher or a product developer, when they want to use data, to make decisions or to get insights? So it's like a hierarchy of needs. It's like a Maslow pyramid, but slightly different. So some people might start, they might actually not have data yet, so they have to worry about, okay, where can I collect this? What type of data is out there? What's the difference between big data and traditional data? IoT is a very big thing at the moment, and I guess it's not going to go away. And then you have to move across to trying to understand your data. How is it structured? How are you going to go about to analyze it? Straight to getting initial insights, maybe visualizing some of your findings. And then last but not least, at the very top, you can also look at a bit more advanced models where you can predict certain things, and that can be anything using very traditional methods. So some of those methods have been applied for decades, or it can be the newer areas in machine learning or AI. So I wanted to highlight a bit about data structure, because I'm sure everyone here works with data and might have come across this. So, it's not always straightforward to deal with a set of data, and you have to kind of keep in mind, okay, is this a nice clean Excel file? Is it well structured, or is this messy? So you have to really know where this is coming from, and to know how or which techniques you can apply to to handle messier data. So messy data could be data that's on a piece of paper, or has a lot of gaps. So how can you deal with that? But it doesn't mean that you can't use such data sometimes. And then also, I think traditionally, when people think about food and nutrition, when they think about data, it's normally analytical data or findings in paper. It could be food consumption data and so on. But I think more and more, people use more alternative data sources, and you can actually do a lot by combining some of those data sets, such as data from market research. There's a lot of market research companies that have a high volume of data. They use it for very specific purposes, but you can also use it in completely different areas to get to results. Alternatively as well, data that can be crowdsourced. Again, you'd have to be mindful of the quality of that data and where it's coming from and what you would like to use it for. And then also something I think that's we're veering towards slowly but surely is to gather more data online, because a lot of it is still done on pen and paper or in specific labs, so it's not very scalable sometimes. So when we're looking at the different applications in industry of predictive modelling, we can look for many things to apply it in the R&D setting. There's a lot of talk this morning about reformulation, and I'm going to show you hopefully some examples how you can actually model that with data. And then also in safety, it's used a lot, for example, microbial safety or chemical exposure. And then also when you look at health, you can look at the impact of different nutritional models on your health outcomes, for example. And equally, a lot of the predictive models can feed in straight into the strategy of a business. So I want to go through just a couple of case studies, starting with something that's been used for quite a while. Actually, it sounds very fancy, but it's actually something that's been applied a lot in science, which is predictive exposure modeling. So specifically when you're looking at contaminants or additives or anything that you would want to make sure that the consumer is safe, you would run an exposure assessment as part of your general risk assessment to determine your consumer safety. And this can be done in a very crude way. You can just look at very high level concentrations in your food and high level consumption. So you need to know the data that you need to use, and you call it a back of the envelope calculation. But I want to show you what would be the impact of doing that. So first of all, we need to know what do we need. So we need to know what do people eat. So what foods do they eat and in what amounts. And also what is the concentration of the substance that you want to look at in your foods. And then normally you just multiply the two and you get an exposure value. And that's done a lot of times just for like initial screening. But you can go into much more detail and basically veer away from this back of the envelope calculation, which is looking at a very crude and overly worst case scenario. So you're looking at an overestimate. And you can veer away towards a bit more refined probabilistic modeling. So how this would look like, you would take data on food consumption, such as the NDNS, for example, which was mentioned multiple times this morning, and you would basically analyze it at an individual consumption level. And you would see, okay, what does this person eat on the first day, what foods do they consume, what amounts do they consume that food in, and the frequency they consume that in. And then next, you want to know what's your concentration of a given substance in the food. This doesn't need to be a maximum level or an average. It can be something, from a range of concentration if you have sample data, for example. And you can also allow for looking at presence probability. So you can basically assume that it's not always present. So you can play around with a lot of data and do a much more refined exercise. And if you do that for each subject in each survey, in the survey on each of the days, you can do all your calculations, such as your daily average exposure or acute, and so on and so forth. And then you can look at where your population lies in terms of safety limits, for example. And just to show you something a bit more practical, so this is a example where we looked at metal mercury from fish, where we applied a worst case scenario in blue here, and then we refined it using a probabilistic model in orange here, and this is our health-based threshold. So in this case it would be a tolerable daily intake, and you can see when you do your refinement, so these for example, at your high consumers, so your 95th percentile, that your population is actually fine and not exceeding health-based thresholds, whereas in your worst-case scenario, it kind of shoots up and it becomes a worry straight away. So that's one example. Another example, and I know Petra from yesterday this morning was giving a really nice example on that, is to look at new product development and how it impacts on health in the population. So this is a case study that looked at potassium intakes, or increasing those intakes specifically in the Chinese population. So for that we used a survey called the China Health and Nutrition Survey, which basically analysed a lot of people and what they consumed in a given time span. We specifically focused on consumers that were 45 years and older and that were drinking milk. And so we basically wanted to look at the impact of a new product that was high in potassium. So we wanted to swap some of the foods within the diet to see what would be the impact. So for that, we first of all needed to know what is the baseline intakes of potassium, and then we looked at a scenario, so where we did a replacement of this new product that was high in potassium, swapping that out with the drinking milk and looking at what would be the impact. And finally, we looked at an impact parameter, which was systolic blood pressure. So within those surveys, a lot of times, those parameters are measured as well. So we would know each individual in this survey, what would be their consumption and what would be their initial blood pressure. And from that, we looked at how our potassium intake increased and reached a bit better the reference intakes. So we knew the shift for each person in their potassium intakes of those consumers. And then going further, we looked at how would that impact their blood pressure. So we could see people moving from a pre-hypertensive stage into the normal tensive stage. And we also did different scenarios. So scenario modeling is something that you do a lot when you do predictive models. Another example, very brief, is you can apply predictive modeling when you want to look at shelf life or stability of your product. So there's a lot of different techniques, there's a lot of different databases out there that you can use, but you could, for example, create something like this, which is a calculator. It's using historical data from different stability tests, for example, and using this data you can build a model that can predict basically if you have a new formulation. So this is a beverage. If you have a new formulation and you want to change it, you can predict whether your product will be stable or not. And for that, there's a lot of different techniques that need to be applied to get to that, including the data validation, looking at outliers, and then your sensitivity and specificity analysis at the end. So another example is in the public health nutrition space. So this is a project that we finished last year, and it was launched at the start of this year by Food Drink Ireland and also by the Food Safety Authority of Ireland, and it was looking at the evolution of food and drink in Ireland, specifically reformulation. So I want to focus mainly on the methodology for that, just to kind of show what type of model that we applied for that. Overall, the goal was to estimate the impact of the voluntary industry reformulation, as well as the introduction of new products onto the market, and the shift in consumer preference in the Irish population. So for that, we used different surveys by the Irish University Nutrition Alliance, which was looking at teens, children, adults and preschool children. And you can see from the dates, like these surveys are very, they're very big surveys and they need a lot of time to run, but you might think, oh, they're very out of date. And that's why we wanted to do this exercise with industry to kind of see how did reformulation since evolve and how did that affect the consumers. And the nutrients that we focused on were sodium, fat, saturated fat, energy and sugar. And this is a follow-on from a first phase where we initially looked at reformulated products only. So, and then we published a paper on that as well.
So, and in the second phase, we added as well the new product variants that were on the market since, because we looked at the year 2005 and 2017, which is a very big lifespan for a product, and a lot of products obviously they disappear from the market or they're being replaced by new alternative products as well. So this project involved a lot of data collection, which I think was probably the most challenging bit. So from those 15 companies that were involved, so these were FDI members, we gathered over 23,000 data points that had to be, analyzed as well before putting into the model itself. Some very high-level key results, and you can download this report online as well because it's very extensive and comprehensive, but to show you over those 12 years of data analysis, you can see some of the product reductions. Some they weren't as significant, but when you look at sodium and when you think about the whole salt reduction programs that are run within Ireland, but also I know in the UK, you can see the impact. In terms of intakes, sugar had the biggest impact on reductions. So that was up to 3.2 grams in children, for example. There was obviously lots more results. And to point out as well, this was the pre-sugar tax. So we kind of would expect it to be gone down even further. And how did we do this? So we used, so we got a lot of concentration data points from lots of different brands, and we wanted to make this fit with those consumption surveys, which might have a food, it's called cheddar cheese, but it could be different brands of cheddar cheese. So to account for the different brands and the different products, we used market share data from Euromonitor. And we basically did this exercise for the 2 years. So we used 2 years of market share data, one for 2005. And then, for example, you can see these would be different products, so they would be different brands, and they all have a different share of a product variant. So if this is cheddar cheese, they have a different weighting to that affect the composition data. And then for the year 2017, we also accounted for new product variants entering the market, and they equally got a piece of the pie of the market share. And for those scenarios, we created one optimistic scenario because we only had 15 companies. They were quite big companies, but we know there's a lot of own brands and a lot of other brands out there. For the optimistic scenario, we basically assumed that all the other companies would follow a similar pattern of reformulation. And for the conservative scenario, which would be a more, I guess, negative scenario, we assumed that the rest of the market wouldn't change. So we would have a range of concentrations, and we would assume that the real impact would lie in between those two scenarios. Okay. So to conclude, or to kind of like emphasize, there's certain challenges when you look at data and trying to apply specific models. Obviously there's a expertise needed for this, and different disciplines need to come together. You have to be aware of the methodologies and also the limitations. Data availability can be a huge issue, because a lot of data sets aren't available or they're out of date as well. And then also data quality, I would say, is a huge challenge. And also uncertainties, which you need to keep in mind when you're doing a pure kind of data analysis. But equally, there are a lot of opportunities, I feel. So you can use data and models to inform certain decisions faster, before running experiments that might be very costly. And also there's a lot of technologies and tools out there that enable you to do that. And also I think leveraging the different multidisciplinary kind of capabilities is a very big opportunity in this area. And that's everything. Thank you very much.